Hello, everyone. In our discussion today, we'd like to go over the fundamentals of Azure Machine Learning. The goal is to basically walk you through the Azure ML service and how you can basically do the entire life cycle of machine learning project through Azure Machine Learning. My name is Mir Alam. I am one of the senior FastTrack engineers. I'll be helping Andreas in this discussion.
Thanks, Mir. Hi, my name is Andreas. I'm a service engineer. Today, we're going to discuss a little bit about Azure Machine Learning.
Azure Machine Learning is a set of services that allow you to perform cloud-scale machine learning experimentation within Azure. As every other resource, it lives within a subscription and within a resource group. In order to provision one, you will have to go through the normal provision wizard that we have, and you can select Azure Machine Learning, and from there, you can just start the creation process. Besides the name of the machine learning workspace, you will also need to provide a couple more resources. So let me give a random name here. This is the workspace name. This is where I will be logging in, and I also have to specify the region. A workspace consists of a storage account, a key vault, application insights, and a container registry. A storage account is where you will be storing various artifacts like intermediate trained models or feature engineers data sets or logs or even the actual trained models that you will have. A key vault is the place where you will be storing your secrets like connection strings, and application insights is all about monitoring the web applications that are going to be performing inferences using the machine learning models that you created. And last but not least, the container registry, which is, as you can see, is a resource that we do not provision by default. And this is because you may not need it if you are going to use the environments and the images that we provide as Microsoft. As with all other resources, you can either select an existing resource or you can either generate a new directly from the wizard.
Andreas, one quick question is why would I need a container registry?
That's a brilliant question, Mir. So
from time to time, you need some dependency, some software dependency that you will need to manually install. For example, if you want to connect to a database that has a operating level ODBC driver that you will need to install, and you need then to connect to that ODBC driver through your Python code in order to reach out to that data source. Another example would be if you have an exotic library that is not the traditional MLflow, sklearn, this type of libraries, which you would like to bake in the environment which is going to be executing your scripts. This is within Azure Machine Learning. These environments are stored as Docker images, and basically you start from an environment that Microsoft has pre-curated, which has the basic dependencies like the SDK that you will need and all the traditional machine learning libraries, and then you build on top of that and you bake in those software dependencies that are needed either for your training purposes or for your inference purposes.
And the container registry is the place where you will be storing that Docker image to be able to use it later on.
Fantastic. Thank you for the clarification. Go on, please.
All right. So the next thing that you will see here is about connectivity. You have two options here. The first one is you go with a public and public access from all network, or go down the networking isolation, which basically brings yet another layer of isolation where no one can connect to that workspace besides those folks that are within the virtual network where you will be deploying these private endpoints.
You can switch between public and the private endpoint option from the time that you provision it.
Let's move on. The next tab is about identity, and so you can, of course, this is a feature not only related to Azure Machine Learning, but any resource within Azure. Most of them you can attach an identity to them, an identity that can be used in order to access various other Azure resources like storage accounts and other things. And there's the system assigned ones, which means that the Azure portal will create a new identity for you named after the resource that you just created, or you can have an already existing user assigned one, which you can then go and attach. In this case, because you are provisioning your resources, you cannot use the user assigned. But if you would like to use one, you can either use ARM templates or Terraform scripts to do that, or in the very first tab, you should have selected existing storage account, key vaults, and storage and container registries in order to do this type of deployment. Then we have the storage account access. You have two options. Either you can go with a credential-based access, or you can go with identity-based access. A storage account has an access storage account key. And this is the key. This is like God mode within a storage account. This means that whoever has that key, they can delete that storage account. They can do whatever they want within that storage account. Identity-based access was something that was introduced later on. In this case, the identities of the Azure Machine Learning workspace is passed through in order to access the resources, either the cluster's identity or the user's identity, depending on the compute that you are using in order to run the commands. And basically, you are propagating the permissions of that identity to figure out what you can do on top of the storage. Of course, this is a much more granular approach, which takes advantage of the rich role-based access control that Azure provides. Unfortunately, in the SDK v1, which is still the GA option that we have right now, not all options can work well with the identity-based access, especially the things that handle uploading files and doing file manipulation things. So if you go with identity-based access, make sure you read the documentation about deprecated functions and whether they support identity-based access. The next thing I wanted to touch is about data encryption, and this is whether you want us to encrypt the data that we store within the machine learning workspace with a Microsoft-generated key, which we rotate regularly and stuff like that, or whether you would like to bring in your own key. The last bit is about high business impact workspace, and this is a setting that basically disables most of the telemetry, and it's only usable for specific organizations that really need this level of isolation. The next tab is about tags. Again, I would highly recommend the governance session regarding tagging and the whole governance of resources within Azure. And in the last tab, you will see the review and where you can verify everything is fine, and you can just start the deployment. In my case, I won't go there because I already have deployed here everything. And as you can see, in here I have the Azure Machine Learning workspace. And if I open this, you will see all the linked services, starting with the storage over here, the Azure Container Registry, the Key Vault, and the application insights. The 4 resources that you saw that I could have provisioned within the workspace.
One quick relevant question is, obviously, we talked about the container registry. I also noticed that we have a storage. What is the main basically background requirement for the storage account or blob storage that we created? Why it is not an Azure Data Lake store?
Right. So first and foremost, if you do have a data lake store, we can potentially use that as a storage. But the storage is the place we use within Azure Machine Learning to dump artifacts and files and logs and whatever else you want to temporarily store. It's the place I can actually go in here and we can have a look on what you can use here. So let me show you what it has. If you go to the file shares, I'm not going yet to the containers, you will see that we have two of them. One is the file store, and we will come back to that when we will start talking about data stores within the Azure Machine Learning workspace. But there is also another one that's called code. And if you go here, you will see that over here, I have all the code artifacts that I will be showing later on. Like here, I have two users that they have their own codes, and this is a Jupyter notebook, and you see there is some YAML files and everything else. So basically, the storage account is used to store the code artifacts that are shared between the members that have access to the workspace. The second thing is the containers. And in here, you will see that we have a couple of them. One of the most major ones is this one, which is the default one, as we call it. And in here, you will see that whenever you upload things from the UI, they will be stored here. Like, for example, I uploaded this Python file, and it got saved in a date within the UI folder, right? So it's the place where you can upload things or temporary files, or if you see here, for example, you will see the cache, and you will see here a couple of pickle files that got generated. So it's the place where we store all those artifacts, intermediate artifacts that we need in order to make the whole pipelines orchestration, training of the models, and everything else.
Thanks for the reflection. Yeah, obviously we use it, but sometimes it's great to see why we use it and how they're related to the overall machine learning project lifecycle. Thank you. Go ahead, please.
Let's go one by one. In the container registry, you will see a couple of things. The first thing is in the repositories. Here is where you will be storing the various environments, Docker images that Azure Machine Learning has built. So this is a Docker image that contains a couple of dependencies that I requested, like, for example, the Python package that I wanted to install. The container registry contains those images, but if you are on a public endpoint, meaning that you're not behind the VNet, you can also use it to actually build images. And if you go here on the service on the task and on the runs, you should see here all those runs that have actually built a Docker container. Let's go back. The key vault. In the key vault, if you go here on the secrets, you will see all the secrets that you have access to. This is a resource where Azure Machine Learning has access to things. So if I go here to the access control, I should be able to see that the Azure Machine Learning's identity, which is the key, you see here, FTA Live AzureML. This is an application that I don't have access to. That's the identity of my workspace. And that identity is actually an administrator inside my key vault. So this is the one who can actually go and see everything for my key vault. If I were to go here on my access policies, this is a user that has access to do this. And I literally just gave the AZFTA demo account permission to list the keys, secrets, and certificates. And I'm going to just add him. You see over here, and I need to click the save button as well. And now that I have access, if I go back, here is my account, the AZFTA demo, and I will refresh and I will see that I have access. And if I go back to my keys and secret stories, you will see that I have access to the secrets that are being stored within the machine learning workspace. And we will see a couple of secrets and why how Azure Machine Learning is saving them. Let me go back to my Azure Machine Learning workspace. The last bit is application insights. And this is a resource where you can get telemetry about various real-time endpoints or whatever we like as telemetry, or we can be storing like failed requests, response times, and all this operational telemetry that we will need to verify that the real-time endpoints that we have in production are performing well. From within the Azure portal, as you can see, you cannot do many things. The only thing that I have seen that's very useful is going down the networking route. And to Mir's point, going here, and if you have a public endpoint, a publicly accessible workspace, to go from here and deploy a private endpoint and then go back to the firewall and disable access from any public network. So that's the only thing that you can do within the portal. Besides that, the data scientist will actually start working within the studio experience.
This is where one more scenario might be interesting, and that is the access control. So for example, you as an administrator, you created the workspace, but me as a data scientist or Christina as a data scientist will have access. How you can ensure that accessibility, and in the context of maybe just defining the areas where I can come in, I can do things, or Christina can come in, can do things. If you could reflect on those aspects a little bit from the access control perspective, that'd be great.
That's a great point here, and thanks for highlighting this. So let me explain a little bit what happened before. If you remember, I tried to go into Azure Key Vault and I tried to give access to myself. I'm actually in this browser, I'm logged in as AZFTA demo. This is the account, where as you can see, I'm a contributor, but I couldn't actually query the Azure Active Directory to find myself. So because I didn't have the permission to do that, right? So I'm literally just a contributor within that resource group. And this is when I switched to Andreas Botsikas, which is the owner account of this subscription. And I was able to fulfill this assignment and give me permissions, give the AZFTA demo account permissions to see the Key Vault. So this means that everything you know about the Azure access control and how you can set permissions on a resource group level or a resource level or on a management group level, everything applies here with machine learning. Now, let's talk a little bit about the actual roles that you can have here. Azure offers, of course, the default roles like owner, contributor, and reader. And this still apply to all the resources. But if I go to the resource group level, and if I go to the access control, I can add a custom role. Now I cannot do this because I am not an owner. As a contributor, I cannot modify anything that has to do with permissions, right? So let me come over here. Let me go to the AzureML live event. And this is an owner account. So this means I can, from this browser that is logged in as the Microsoft account that I have, I can actually go and add a custom role. So in here, I can create something like a data scientist role, data scientist. Perfect. So in the next stage, I can add permissions. And in here, there is this nice wizard that can guide me to select the permissions that I want to give to my data scientist. So if I start searching for this, machine learning resource provider, this is the one that I have. And over here, I can start drilling into the various permissions I can give. For example, I may want them to be able to access my clusters, but I don't want them to write or delete those clusters. Or, for example, the jobs. I definitely want them to submit jobs. Instead of going through this list and figuring out what is what, I can definitely go into my documentation and search for Azure Machine Learning, custom roles, and this is an RBAC, meaning that is the role-based access control that we have in all of our resources. Here, this is the link I was looking for. So manage access to an Azure Machine Learning workspace. I can see here there is actually an AzureML data scientist role that are built in. But over here, you can see here that they give you this type of actions and not actions that you need to put to give to your data scientist. So let me show you a little bit what this means. I will just add those things for now, and I will move next Here is the assignable scopes. This means that where I want to be able to assign the scope. If I'm creating a custom role, I'm going to be able to assign this either on a management group, on a subscription, or in this case, I'm only going to be able to assign this role within this specific resource group. I can definitely change the scope, but for now it's fine. And the next thing you will see is this JSON file. And as you can see, this JSON file looks very close to what you see over here. The main difference is that this role is giving every action to the data scientist. I allow you to do everything. And then I go into the node actions and I do not allow you to delete anything. I do not allow you to modify my workspace permissions. I do not allow you to change anything on the computes. So whatever I provision as an administrator, that's all you have. And I do not allow you to change anything on the authorization aspects. Also note that the star here is acting as a wildcard. Most of the customers, they're fine with a normal contributor and owner, but if you do need to modify something, then the custom role is the way you can go. And now, perfect, yeah, it has a scope, actions, and not actions. So I'm just going to create that, and you see that now we have a full list. And now that I have created this role, I can go in and I can add a role assignment, and I can search for the data scientist role, and I can move forward. I can select Christina, and I'm gonna just assign her that permission. And this means that from now on, Christina will be able to do only the tasks that and data scientist is allowed according to our documentation.
Fantastic.
These are actually the things that you can do within the portal, and basically a data scientist will just need to launch the studio, which is basically a dedicated experience where data scientists are working and they're doing their experimentation, they're reviewing the other algorithms, they're trying different variations of the model, and then in the end, decide which is the best model, register it, and deploy it to production into either real time or a batch endpoint. The first thing that you will notice is that this is a dedicated URL. It's called ml.azure.com. If you do decide to go that route, you will end up into this UI where you can have access to your tenant, your Azure Active Directory tenant, and then you can select which endpoint do you want to access. You can even define the quotas. This is something that the admins are able to do, like how much CPU can I use? And in my case, I'm over here in this workspace. Let me guide you through what you can see here. So the first thing is over here on the top. From here, you can switch tenants. So this is Azure Active Directory. So if you have your personal Azure Active Directory and your company's one, this is how you will be able to switch between those two. Over here are some very helpful information about which workspace you are currently connected. And in fact, you can even download the config file. This is literally just a pointer. When I want to connect to my machine learning workspace, this is the information that you need. And we will see this file later on the SDK side. Over here, this is the fastest way to reach to our product group. This is feedback that we triage on a daily basis. And you can tell us about the things that work fine for you or the things that don't work that well for you. And you can even include the screenshot. And if it's okay, you can also specify your email address so that we can reach back and we can talk. On the help side, you can get access to various great tutorials that will help you get started. But if you are behind a virtual network, you will also find this tremendously useful tool, which is the run diagnostics on the workspace level. If you are behind a VNet, there is a lot of networking and isolation and a lot of rules. You're basically trying to prevent your data from being exfiltrated, right? So in these cases, you may end up having some admins be super careful and not allowing things that they should have allowed. And running this workspace diagnostics will help you explain to your admins why some things should have been open. On the settings side, you can see general settings, including the regional formats like the date and values and all these type of things. Here on the other side, this is the menu, and you can actually collapse or expand that clicking here on this burger menu. And the menu is split into 3 sections. This is the authoring experience, where you will be authoring various machine learning experiments. Over here, you are going to be tracking the various assets, things that you are going to be storing while you're doing your experimentation. And the last bit is about managing the underlying infrastructure. And with that, I'm going to start with the actual compute. In the compute, this is the section where you are deploying all those CPUs and GPUs that you will be using either to explore your data and to explore various variations of the model training, or deploy the clusters where you will be using to do the heavy lifting of training on top of thousands of data, or even the clusters where you will be deploying endpoints, real-time endpoints that some other system will be consuming in order to make inferences with the models you produce. We will start with the very first section, which is the compute instances. This is basically, you can think of this as the machine you have in the cloud. It's a virtual machine that you can use. Microsoft is handling the underlying operating system. So a couple of months ago, this was an Ubuntu 16. And one day I closed it down. The next day it started up and it was Ubuntu 18. Microsoft has bumped me up into version 18 because Ubuntu 16 was deprecated. That's the virtual machine where Microsoft is holding the whole operating system. You do not get to change that. You are only responsible for the Python packages and the Jupyter kernels that you will be using. These are the things that you control. Within that compute, you have access to various applications, like, for example, Jupyter Labs. It first went to the Azure Active Directory. It authenticated me with my identity, and then I got access here to the Jupyter Lab. Or if I open here, I have access to Jupyter, which is a far simpler UI. Or I have access even to RStudio. And as you will see over here, this is the name of my machine, AZFTA demo. And in here, the URL that I'm accessing is actually AZFTA demo, and then there is a dash, and then there is a port. So literally, this URL that you see here, it is a URL that is accessing port 8787 on this machine, and this endpoint is protected with Azure Active Directory. So only I can access this.
Does that mean that isolation for compute instances is by the users, meaning that whoever creates the compute instance, they only have the access to it?
Exactly.
And I was thinking from the perspective of, can we create like a common compute instance that could be used by few of us, like myself and Christina could use this at the same time? Is it possible even?
So the compute instance within the machine learning workspace, it is only accessible by the data scientist who has been assigned to that compute instance. There is no way currently to access resources in there.
And Andres, can I create a compute instance and assign it to you?
That's a brilliant question. So let's go through the create compute instance. So actually, Christina, because I assigned you the data scientist role, you are not allowed to create a compute instance within here because I explicitly deny you to write on the compute instances. So in order for me that I have access to give you a VM that you can work, and let me call this Christina's VM, Christina's compute instance. I will be able to select whether I want a GPU-based machine because I know that you're into deep learning and all this type of things. So I'm gonna just give you the biggest NC series that I have. I'm suggested I can actually find even bigger ones if I want to. And what I can do over here, I can assign this to over here. So now I was able to select the user because I was able to query the Azure directory. And I can even give you SSH access, virtual network. I can attach that compute instance into a virtual network. And I can even set up, provision you with a setup script. Within the Azure Machine Learning Fundamentals live event, we have a demo which actually provisions a compute instance and already clones a GitHub repository so that we can have it in there. So if I do, and if I continue and I just provision this, you'll see that this is assigned to you. If I try to access the Jupyter notebook or anything else, I won't be able to do that.
One question that I see typically is around this isolation is, okay, so for the team, could we use one compute instance? Looks like that's not possible. And also the other aspect that I see is like for the training, instead of using one compute option for each user or for each data scientist, could we use a specific compute option or compute choice that could be leveraged by all the data scientists when they try to train their models? That's what I see as a question.
Right. So let me start with the first one, right? So this is a compute instance. This is dedicated to me. If I click over here to terminal, I can do a git pull. I can go to let me go a little bit more up. Go to FTA Live. This is the repository that got cloned, and I can do git pull in here, right? This means that pulling, it's actually, this is a public repository, so no credentials are needed. But if I was working on a private GitHub account, then I would need to have my own SSH keys. So literally, I would have in here in the .ssh, I would have a certificate, which would have been the one that would be authenticating me against GitHub account and would allow me to pull these private repositories. So this is the reason why the compute instance is not something that we can easily share between data scientists. It is supposed to be your own personal, because you will be storing in there your private keys, things that will give you access to the resources where you have access to. This is also a compute, and this compute is firing up the notebooks experience, which you will be able to show us a mirror a little bit down the line, right? So this is a compute that I have to spin up in order to fire up this notebooks experience. But moreover, this is a compute I can use in general to perform whatever action I want. So within our demos that we are going to be doing today, I will have to select a compute. Where am I going to have to run this code, this piece of code that I want to run? Either this is a machine learning training, or it's an inference, or it's a exploratory analysis I want to do on top of my data set. It doesn't matter. It's just a piece of code that I need to run on top of a compute. And this is where I will be able to target my own compute instance. I, as a data scientist that I am assigned to this machine, I am able to use it in order to run some preliminary tests. And ideally, this compute shouldn't be as big as the one that I just provisioned, an NC24, which is a very big machine, right? It should have been something small, but big enough to allow me to run my notebooks, run my experiments with as limited data sets, things like that. And when I want to scale out my efforts and do parallelization, I will need to move into the next aspect, which is the compute clusters.
Keep an eye on the request from the customer that they would like to leverage this cluster as a common cluster for the team to train the jobs, train the models. If it is not possible, let's explain it. If it is possible, let's explain it as well. Like, this is how you need to plan.
Perfect. So the compute instances, as we said, you're right, they have this column that is they assigned to. So literally, this is something that is assigned to a specific user. So this is only a single user that has access to this workspace can actually access this specific compute instance. The compute clusters, on the other hand, these are resources that belong to the workspace. Everyone that has access to that workspace can utilize those compute clusters. That is first and foremost shared for everyone. Everyone can schedule a job there, and they can scale from 0 to whatever number of computer nodes you want. For example, in this case, this is a cluster that used to be 0 to 5. This means that when I wasn't doing anything, this cluster would scale down to 0 and it wouldn't cost me anything to have that registration. Right now, I'm going to be adding one hot standby and I'm going to click update. So basically, I'm going to be provisioning a VM that is going to be right there waiting for a job to come in. So the next job that I'm going to run, and I'm going to target, hey, run this on top of my GPU cluster. The GPU cluster will already have a node and will be able to take that job and run it immediately. Otherwise, I will have to wait for around 3 to 5 minutes until this cluster can resize.
Okay, but will not this be from the cost perspective, if you want to minimize the cost, will not this be a detriment to my cost planning? Because there will always be one node running, and that will keep incurring the cost because it is always running, even though I may not have any job running at any point of time.
Right, you're absolutely right. So if I have a cluster that has a minimum 1, then yes, I have a cluster, a compute node that is sitting by. I'm paying for that. So what I advise my data scientist teams is that when they come in the morning and they are gonna spend their whole day working on that project, which is in this workspace, instead of having them wait 5 minutes for every job they have to, to provision the VM and then run the job, I tell them, okay, in the morning, you just do this edit, you put in a hot standby, and actually every day at night, I have a script that runs and goes through all my workspaces and finds all the compute clusters that I have, and then just scales them down to 0 so that I can save some money. And if they accidentally forgot to scale this down at night, I have that script that gets me covered.
Thank you for the clarification. Yes, that's very helpful.
This script is over here in the auto shutdown, and you will see here that I'm basically doing 2 things. I'm closing down Azure Container Instances, all the demo instances that we will see later today, and I am also closing down all the compute instances. And this is the script that basically attaches to my workspace using the managed identity of the compute cluster. And then it looks at all my compute targets, all my computers. And if it is a compute instance, like the personal VMs that you saw before, I'm just stopping it. If it is an AML compute, which is the cluster, then I'm just updating it with a minimum number of node 0.
Fantastic. This definitely is going to be very, very helpful. Having a script that we can leverage to essentially automatically shut down, meaning put it to like node minimum node to 0, right? Thank you.
I think we have covered the compute clusters, and we will be able to differentiate about compute instances and compute clusters later on the examples. Let's move on to the inference clusters, and I'm not going to stay too much in here because this is what we refer to as the platform V1. The inference clusters was the idea where you could actually create from over here a Kubernetes cluster where you could be easily deploying machine learning models, and you can operationalize them fairly easy. You will see this in a sec when we will deploy our first model. But we got a lot of feedback that most of the enterprise customers do not really like data scientists deploying the Kubernetes cluster on their behalf, but rather than attaching a Kubernetes cluster. And if we come to the attached compute, you will see over here the ability to attach Kubernetes, which is now generally available. And basically what you can do is you can find the Kubernetes cluster within your subscription, and you can attach a specific namespace inside the Azure Machine Learning workspace, and you can use that to do either training or inferences. So the previous version was only meant to do inferences, while the new version, the one where you are just attaching a Kubernetes cluster, you can use it for whatever you like. For example, if you have a Kubernetes cluster that during night it's being idle because you don't have any traffic, then you can use that capacity that you have standby, and you can train some machine learning models. And with that, you don't even need a compute cluster. Whatever you see here, and you will see it clearly when we go through the AutoML experiments and everything else, you can target whatever compute you like. It's just a matter of attaching it so that you can make it available to your machine learning workspace to run various tasks. The next thing that I would like to touch is the data stores. And in here, we are talking about, this is my connection strings to the various data stores from where I can pull in data. And as you can see, we support a lot of options, the Azure-based options, because we want them to be as close to the compute as possible so that we can, spin up those clusters, so many nodes that will be able to consume those data. My best practice advice is that you should target for blob, because that's the most cost-efficient approach that you can get. A blob or data lake, of course, if you want to do take advantage of the control access that the data lake offers. And this is the most cost-efficient medium that we have in order to store data that can scale up and can accommodate all those compute clusters that want to train those machine learning models in parallel. So a very common task that you will be doing in data science is will be doing hyperparameter optimization, like training the same model over and over again with different instantiation parameters. And this means that you will have at least 10 or 20 instances reading exactly the same data over the same data store. So if you had the SQL database, for example, and you were reading from there, you will have to scale up that resource so that it can accommodate the traffic, the incoming request, the same select star from table training data request that you will be sending in from those clusters. So this is why I say that a blob store or a data lake can easily scale to 20,000 requests per second, and you can even raise a support request to raise that even higher if you need to. And you will never find the most cost-efficient medium. Having said that, when you try to register a data store, you will have to specify the authentication options. You can, for example, for a blob store, you can use either account key or a SaaS token. For the Azure Data Lake, you can definitely go with a service principal, because then you have better fine-tuned control. Or for the SQL database, you can go with either service principal or a SQL authentication. And of course, all those secrets get stored within the key vault that we showed you over here into the that is related to the Azure Machine Learning workspace. That's a way of registering all those connection strings that will give you access to the engines that have the data. For example, over here, if you remember, I showed you in the beginning this Azure blob and then a weird GUID, which is basically the container within the storage account that is attached to this machine learning workspace. And as you can see, I'm accessing this through account key. So this machine learning workspace was provisioning using the account key access. If I was using it, if I update and say no here, save credentials in the data store, then I will be accessing this data store using identity-based approach. And this would mean that my identity, the identity of the data scientist, passes through the machine learning workspace into the storage account. And if I, as a data scientist, have access to the data, I will be able to see it over here. Otherwise, I won't be able to see that.
One interesting thing is that we should be able to use the Azure Synapse Spark compute as an option to train our models, machine learning models, for example, right? How can you do this? As I was thinking that probably is what link services is alluding to, but that's one of the managed option that I can see it is related to. So it will be beneficial for us to complete the discussion under the managed options.
Right, so let's go over here on the attach, and over here you can attach various things like Synapse, Spark pools, Azure Databricks, Data Lake, and all this type of thing. And I think that if you click here on the Synapse workspace, this is basically very well related to the linked services that we have over here.
Say as a user, you want to leverage machine learning studio, machine learning workspace for all things data science, but then you also take advantage of Synapse because we know that Synapse is one-stop shop for all things analytics. We want to actually use that as a target for our machine learning model deployment for the production scenarios. I think that's where this becomes relevant. So if you click on add integration, it will walk you through, and then you definitely would have to have the Synapse Spark pool created first. Otherwise, it's not gonna show you. But that's how they are related, and that's how you can create the link services. And once you have it, as you already showed on the compute option, that can be used as a target for your machine learning model deployment or model training in general.
Perfect. So basically, this gives you access to get a production grade Spark cluster that can run Spark jobs. For example, if you're doing PySpark or anything else, this is the way you can link production ready Spark pools that we have within Synapse and bring them within Machine Learning Studio.
Correct. Absolutely. That is the scenario. And we see that ask for the customers coming in. There is one customer that one of my colleagues is working on right now. They asked that this very question that, hey, I love Azure Synapse because it has everything. But I also see that Azure Machine Learning Studio as a data scientist is a great environment for me. Now, how can we just mesh these two together? For example, where does the integration come from, or what can I use as an integration point? So that's what we walk through with them. Like, okay, so you do all the data scientist activities, test your model, train it, deploy it, everything that. But then when you're ready to do a production, and if you choose to use Azure Synapse as your target compute, then this is the place. You use the link services option to link it as a target deployment compute option.
Does it mean that I will see this Synapse Spark pool in my compute attached compute menu, attached computes, or not?
Yes, you should see that. I mean, basically, it works both ways. If you create, so go to the compute option, Andreas.
Sure.
Attached compute, and if you walk through on this space, this will create a link service under that managed option, and vice versa. Makes sense, Christina? So that means
if you attach it from here, you will have automatically created linked service.
Correct.
Okay,
correct.
Great.
Yeah, so that's one definitely interesting scenario coming in, and obviously it will improve over the time. And as we see more feedbacks from the customers coming in as far as what else they want to see, how else they want to make it more, like, for example, I can easily see that, instead of having just a complete cluster as one destination for my testing, before I go to the production, I want to test against this attached compute, which is basically the Spark pool under Synapse, right? I'm going to use that going forward. And then definitely that option will probably be more dominant, and it will open more doors for different interactions or integration questions. That's how I see it.
Perfect. And I see here that yes, if I had this is my other account, and where I have a Synapse workspace, and I can just select it, and over here I can select my workspace, and then I can move forward and I can select my Spark pool, and this basically allow me to go back here into my attached computes. And once I have made the link to the Synapse and I have it available here, I will be able to attach it as a compute so that I can use it within my workspace. That's brilliant.
Yeah, we have the documentation for a quick walkthrough, but for today's discussion, we do not have a lab that we could just show you. But at the same time, the documentation is very self-explanatory, and we demoed it with the other customer. It should work just like that.
Perfect. So let me go to the last tab, to the data labeling, and for that, I'm gonna just switch the tenants. I'm gonna switch directory, and I'm gonna go to my FTA demo Azure Active Directory, and I'm gonna visit another workspace. So you probably have seen it by now that I'm switching between workspaces and Active Directories and everything, but you should always think of the workspace as a security boundary for your project. Everyone who has access to the workspace should have access to all the data that this workspace can access. So if you have a highly confidential project where you want only a specific group of data scientists to be able to work with, you should spin up a dedicated workspace with a dedicated storage account. I would even argue with a dedicated container registry, although I know it's a little bit costly resource. But the reason behind this is that although you may have been using the latest identity-based access to reach out to the data, you may accidentally store data into the data store that is actually the default one. If you remember, in my previous example, I was showing you here over here. If I go to the data stores, you will see that this blob store is actually the default data store. And this is a data store that it's just a storage account. We are accessing it with a storage account key. It doesn't allow access with identity based. So I accidentally can grab data from a highly secured resource where only I can have access to, and I can accidentally dump a summary or something else into the workspace blob store. This is why we advise that if you are dealing with this type of critical data, you should definitely isolate them with a separate workspace. Let me go back into my workspace, into my other workspace. This is called the ML Workspace Demo for AI/ML. And I'm going to go over here to the data labeling, where I have a couple of projects. So data labeling helps you organize and run data labeling efforts. And we support quite a few types, like image classifications. We also support text. And as you move forward with the wizard that we have over here, you can actually bring in a vendor, bring in labor force that can do the labeling for you. So you are organizing that, hey, I have these 1,000 pictures that I want to label, and I can ask one of those vendors to come in and help me with these labeling activities. Or if I don't want to get another vendor, I can just set up this project so that my internal resources can actually come in and help. And over here, I'm going to select the data that I want to use. I'm just going to select a random data set. Over here, I'm able to do incremental refresh. So as I start bringing in data into the data set, so I'm pulling in data with my Azure Data Factory pipeline or my Synapse pipelines that are bringing data from my on-prem system into cloud. This will mean that I would like incrementally every now and then to be bringing in those images and those texts so that my team can continue labeling them. And over here, for example, I have to specify a label. So I'm gonna just put a dog and then a cat. So that's the two cat labels that I'm gonna be tagging for. Over here, I can give my HTTPS, Azure DevOps wiki page URL so that they can go in there and they can look at the further instructions, or I can just tell them over here with a short description that just label if this is a dog or a cat. So these are the two types of instructions that I'm going to be giving to the labelers. And then the last bit is all about enabling ML-assisted labeling. So once my labeling force, the people that are labeling images, have reached a significant volume of data, I can actually start training machine learning models that can start giving tips that, hey, I see a cat over here, or I see a dog over here. And then the people who are labeling the images, they can just confirm that, and they say, okay, let's move forward. Yes, that's actually a dog, that's actually a cat. And over here, you can enable this ML-assisted labeling, which will take care of, running this job periodically every now and then. Let me show you how this looks like for for a hardware labeling project. And this is just a labeling, right? As a labeler, if I come in, I will just click on here on the label data, and I will see the instructions. Remember the ones that I said, just label dog and cat? And I will just say start labeling. And over here, I can select whether this is a wrench or a hammer. This is a single label project, and I'm going to submit that, right? And as you can see, we have a very rich shortcut scheme, which basically allows me to do fast selections. Like, for example, it's with Control S, I can select, I can move forward, and with 1 and 2, I can select 1 for wrench, 2 for hammer. And you see, I'm just moving forward like this. And yes, this is a hammer, this is a hammer, this is a hammer, this is a wrench. And of course, this is how the labels will look at that. And I can go back and forward, and I can fix things and everything else. Let's go back into the project owner. And over here, you will see that the training, there has been training that has been trying to create a machine learning model to help my end users. But for now, I haven't had something that is reliable enough. Let me go back into my data, and I will see that this is my data set, and here are the labeled data. And if I scroll through this, you see these are the ones that I just labeled, and I can either reject them and send them back to my pool so that another labeler can actually pick things up, or even the same one if I don't have that many, or I can just approve it and then move forward and say that, yeah, this is the label that that should be. So this is what the labeling project looks like. And there are all sorts of options. I can edit, and everything can be exported to either the COCO format, file format, which is very compatible with a lot of tools, or you can even store it with AzureML dataset, which can then trigger an AutoML computer vision project. We will see that when we reach to the AutoML, or I can even just export it as a CSV. Another project that I have is over here, object detection. And if I go in here, you will see that while labeling task, I will have to do this type of labeling, and I will be able to basically do segmentation. There is even, no, this is object detection. If I wanted, the other type is segmentation, where I literally have to click all around the object in order to segregate that from the rest of the image. So there are all these type of options, and we have very similar capabilities into text, where you can actually go in and you can highlight some text and say that, hey, this is an entity, this is the buyer, or this is the house that I'm willing to buy, and basically label those entities, and then I can run just another buying contract, and I can have these entities extracted.
Once they level the data sets, how they're going to be leveraging that level data sets is probably one question that I can easily see coming, right? To my understanding, when we are doing the leveling, the idea is that when you are working with the data sets for your data science projects, having the level data set helps you tremendously to basically avoid some of the data feature engineering exercises. That's what I know about where the data labeling comes into play. But let's just say that you did the labeling, you're done with labeling. What next? How does it help you in your data science projects?
Right. So data labeling is basically constructing the data set that you will be able to use to train machine learning, right? And as I said, you can export this with COCO. COCO format is a data set. It's a data set that you can use with tools that are out there to train, to customize your own, customize various machine learning models that are out there to be able to recognize what you want. For example, there is this YOLO classifier that has already been trained with a lot of data. And what I can do is I can transfer learning, basically take an already pre-trained model that can understand cats and dogs, which basically means that this model can understand the lines. When it sees a cat, it can understand what an ear is, what this corner will look like, what is, and segregate objects based on that. And I can then train the same model to be able to understand the difference between a hammer and a wrench. And how is this possible? It will transfer its learnings about segregating this thing and understanding that this is part of a hammer. And so I will be reusing what the layers that of the neural network that can easily understand this thing, and they can transfer the learning that in the end, it's basically going to say that, yes, this is not a cat, this is actually a hammer, or the other thing is actually a wrench.
I think the idea is that, because you already did the labeling and it has some learning because we did the labeling through the machine learning assistance, it already has some knowledge based on the shapes and the in the different lines on the object itself that we detected. So it can transfer that knowledge, meaning it is actually saving me a lot of time when we are taking the label data set for our next machine learning exercises or machine learning problem solving, correct?
Exactly. And within Azure Machine Learning, if you decide to export this labeled dataset, you can actually use this new capability that we have, and you can actually train computer vision models with AutoML, something I will show you in a little bit what AutoML looks like. And this is the file format that we are storing this information. Like, for example, this is the image.1, this is the image format, and this is the label, cat or a dog. Like not in this example, but in the one that I was showing you before, where I was labeling hammers versus wrenches. This is exactly the output that you will get.
We can now go to the authoring experience. Especially, I'd like to touch at least the automated ML, and then how this ties to our data assets or assets in general for machine learning project.
So let me guide you through a data set, and then I can kick off an AutoML. I can explain a simple regression model, and then you can take over and you can show us a classification model if that's okay with you.
Sounds good. Not that we don't have to go very details, but at least guidance as how this ties together. Like maybe we can just take the automated ML as an approach, and then every other related assets that ties to like data as an asset, job as an asset, pipeline as an asset. I think one example of automated ML should do. Just go ahead, please.
So let's start with the data store. As I said before, here is where you're setting up those data connection strings. And in here, for example, if I go and search the samples, I have here that diabetes data set. And basically, it's just a single CSV. And as you can see, this is a data set that I have uploaded. This is the sklearn default diabetes data set. It's very unfortunate that it's named, the features are named 0, 1, 2, 3, etc., etc. So it basically has 10 features and one column that is the target column. And as you can see, this is a numeric value. And you can think of this data set like this is my pressure, this is my age, This is my glucose level. And these are the values of the measurements that I did 1 year ago. And this is the value of my, however we measure diabetes 1 year later. So the goal is to get this data set and to be able to train a machine learning model that when I give it my exams now, it will do a prediction of my diabetes level, let's call it like that, in 1 year from now. So as you can see, I have already uploaded this into my blob store in my default storage, and I can go over here into my data and I can start. I can literally just upload this file from my, if I have already got it on my PC, I can upload it. But in a more enterprise ready scenario, probably you would have something like a Synapse or Azure Data Factory pipeline that is going to be bringing in those data and will be storing them into a data store that's connected to your machine learning workspace. So this is why I'm going to go here to go to from data store. I'm going to call this diabetes and then 2022 0707. And over here we have the concept of a tabular dataset or a file dataset. If you saw before, it's just a file, it's a CSV file, but because it has tabular data in it, I can actually read those and I can do far more things. So I'm going to select the tabular one and show you what this looks like. I'm going to select the default data store that I used before, and I'm going to use the browse facility in order to go over here to my samples, and then I'm going to select diabetes and V1, and I'm going to just use that. If I wanted to, I could just use something like this. I could put * over here, so pull all the data from all the folders in there that end up with CSV like this. But for now, it's just I'm just gonna leave it as is. So I'm gonna just lead over here and I'm gonna read all the CSV files that are within this folder. This is very useful, especially in scenarios, as you can see that I want to have multiple versions of the data sets. So a very small sample, which I want to run my experimentation, then a bigger sample, and then even more. So I can register this as different data sets and I can use it throughout my experimentation. In the next step, as you can see, it's validating. It takes some time. So it's looking at the file and it actually automatically detected that this is a delimited file. You can see over here that these are the other file formats we support, but this wizard is smart enough to be able to understand most of the settings. If something is not right, you are allowed to modify it here, of course. The next step is to be able to define the schema. This is a CSV file, so this file doesn't store what are the types. So it doesn't understand anything about types. If you wanted to store the types, like this is a decimal, this is an integer, or this is a string, you should have gone with a more advanced file format, like a Parquet file or something like that. In this case, since everything is string, Azure Machine Learning knows that, and it already understood that, hey, this looks like a decimal. If you remember my data set, it was already normalized, and it already had those dots. So this is a great selection for me. But if I wanted to modify something, I have the flexibility over here to do this edit. On the last side, I have to just verify. And over here, I can even select a profiling activity, which we will actually see a little bit later. But for now, I'm just going to create that data set. So once I create this data set, if I go over here, and this is a version metadata store. We do not version your data. If I go behind the scenes into the storage account and I delete that CSV file, then you will see here the files in dataset will drop to 0, and the file is going to also drop to 0 because I literally just deleted the file. If you want to version the data, you should take care of that on the data store layer, meaning that if you wanted to create a V2 dataset where you modified a couple of records, then you should definitely just register and create a replica of the files and register it as a new version using exactly the same wizard that we just saw. Having said that, the rest of the data are over here. You can add some descriptions, you can add some data tags so that you can filter the data sets. And over here, you can see a piece of code that gives you immediate access to that data set through your code, the SDK that we saw a little bit before. And over here on the Explore side is where you will be able to see a sample of the data and a profile. So this is basically, as you can see, it's 442 rows. And over here, I can see the various features. And over here, for example, I selected the feature number 2, which is the third feature. And over here, I can see that, hey, there are these outliers over here that are above 0.1. Let's keep that in our mind for a later analysis of the machine learning model that we are going to be doing. So this is a profile that we do on top of your data set, and you're going to get this for free if your data is less than 10,000 rows. But if your data set is more than 10,000 rows, this is where the generate profile task comes into play. And if you remember, that was the checkbox that I didn't select back in the wizard. So in order to generate a profile, I need to specify where am I going to run this job. And this is where the computes come into play. As you can see, I can select either my own compute instance, which is already running, but if this is a big data set, I would probably want a compute cluster to be able to handle this. And I know that I have already scaled up my GPU cluster and I have added it a hot standby. So I can definitely just use that and get it over. And another option that you can have here is the profile output location. Remember when I was talking about sensitive data? If I drop it into my default workspace storage account, that may be accessible from everyone because they have access keys and stuff like that. But if I have this highly privileged data, I would probably have selected something like a data lake, where the data lake can apply this scheme of authorization that only I and the selected people have access to. And this is where the profile output would be placed. And the profile is something like that, right? So let's order a generate profile, although in this case, it's not needed because it's very few rows. But this will basically just schedule a job. And if I go here, you will see that I'm transferred here into the jobs. I can see that this is basically a dataset profile. So if I go over here into my jobs, I will see that in the experiments, there is this experiment that's called dataset profile, and I can see this job that is currently running. I can also go back into my compute, in my compute cluster. I can go into my GPU cluster, and over here on the jobs, I will see that I have this job running. So these are the two places from where you can actually access the job. And let's have a look on the job. A job is nothing more than a piece of code that is running and it's producing some logs. Over here, you will see that it's basically pulling some Docker image and basically an environment that is curated by Microsoft. So we have owners of that environment, and you will be able to see it here on the environments later on when Mir will be doing the demo. In the outputs over here, this is the driver log. So this is the actual logs of my code that is currently learning, and I see that it's almost done. And basically, if I go back into the overview and I refresh, it should be completed. Perfect. So basically, I just saw that everything is done. And if I go back into my data set, I will see that in the Explore, if I had a limited profile, I won't be able to see this, but now I can see the full. Let me show you the error. Over here, Explore. You see over here, this is the warning that you will see, that this is basically a dataset that was generated with only the first 10,000 rows. And if you would like to see the full profile, you should click generate profile and run this activity on top of your data. Once I have a dataset, and in this case, a tabular dataset, I can start experimenting. And over here, I can go with AutoML. And in AutoML, I'm gonna just go and select my diabetes dataset that I just selected. I'm over here on the AutoML. I just selected the tabular dataset that I want. And right next, I will be selecting an experiment. If you remember, the dataset profile was an automatic experiment that was created, and under it, it was all the dataset profile activities were logged under that. In this case, in my case, I have created another one which is called Diabetes AutoML, and this is where I'm going to be putting all my efforts regarding this diabetes dataset. So later on, I can, go in and group by and see all the results over the time and what I have tried and what I have not. Over here, I need to specify my target column, and in this case, it's the column, the feature that's called target. I will need to specify, again, a compute type, either a compute cluster or a compute instance. In this case, I'm going to select the GPU cluster, and then I'm going to go next. The next task is all about selecting the actual task. So what is this about? And as you can see here, I automatically understood that this is a regression model. You'll see later with Mir, that's going to do a classification model. It will automatically select the classification setting for him. And as you can see, these are the various tasks that you can do. What I'm going to focus is over here on the additional settings, where you can definitely define your own primary metric. What are you trying to optimize against? And you will see in the classification, of course, we have different metrics rather than in the regression model. I will order a model explainability, and this is something I will show you a little bit later. And over here, you have the ability to either allow all models, let's explore all options, but I would like to exclude the XGBoost regressors because I know that they overfit on my dataset based on science literature. Or I can do the other way around. I can allow no model, and I can tell it, hey, I want you to find between those three models, what is the best model to tackle with the data set I'm giving you. For now, I'm just going to go with all supported models. Over here is a section that's called exit criterion, but I really like calling it as your budget. How much are you willing to spend in order to find the best model? In this case, I'm going to be really cheap, and I'm going to just need to spend half an hour searching for the best model. And if I want, I could specify that, you know what, for the R2 score, I want it to be more than 0.21 or something like that. I can do an OR combination, or I can just let it run for half an hour. The last bit is the max concurrency. And you will see that over here, because I have a cluster that can scale up to 1, I can have a max concurrency of 1. But if I had a cluster that can run up to 4 nodes, then it would automatically be 4 over here. And I could limit the concurrency and let it run on a single node. So in this case, I will just read 1 node. And by seeing this, I can calculate how much this experiment is going to cost me, because I'm going to be running a single node of this specific cluster that I selected in the previous step for half an hour. So if it's D4, it's going to be really cheap. Let me go save. Over here, we have the featureization settings, which basically is telling you what type of value do you have. AutoML is doing a really great job understanding automatically the settings, but if you would like to force, for example, a field that it is a categorical value instead of an integer, for example, a product ID, where you have only 3 products that constantly repeat, AutoML will understand that this is a categorical value, but if you want to push it that, yes, this is a categorical value, this is how you can actually specify it over here. For now, I'm going to just leave it auto. And the next thing that I can do is I can define the imputation logic. How is the model going to treat missing values? Is it going to use the most frequent value? Is it going to fill with a constant? For now, I'm just going to leave it auto. And I'm going to click save, and I'm going to click next. The last bit that I have to specify over here is the validation of the dataset. So basically, this is a new feature that we have in AutoML, where you can bring in your own dataset and validate the best model. So imagine that you have a golden dataset, a dataset that you do not use for training, but you use to evaluate the best models that you create every time you run this wizard. So this is the golden dataset that you can use to evaluate various experimentations that you have. For now, I'm just going to leave it like this, and this will spin up the AutoML wizard. If I want to repeat this process by modifying something like removing an algorithm, I can just click the edit and submit, and that will bring me back to the AutoML wizard, and we have all the settings already up, and I can just go and modify those settings. Now, I'm not gonna wait for this. I'm gonna go back. Let me go back and into my jobs, all jobs, and try to find a 30-minute AutoML run over here. For example, this is a nice experiment. I can modify the names over here, so I can give it whatever name is, so I can easily find those things. If I go here on the data guardrails, and I have 3 statuses, passed, done, or failed, and clicking here, you can see more details about what has been done and how the problem was fixed, while the past are perfectly fine. And over here, I can see the various models that I have. As you can see over here, we are trying different combinations between a scalar and a model. And as you can see here, I have the, let's take, for example, here, standard scalar wrapper elastic net. This is the one. And over here, I have another standard scalar elastic net, but I just opened it here, which has different normalized root mean square error. What's going on? Is this a bug? Is this an issue? Let me bring this together side by side. So let's have a look inside this model, and let's have a look on the hyperparameters. And as you can see, the scalar is the same. So basically, it's using exactly the same properties as a scalar. But over here, alpha is the same, but the L1 ratio, the lasso ratio, the one that defines how flexible the model training is completely different. So what we are doing here is we're performing hyperparameter tuning optimization. If you have figured out that, you know what, ElasticNet is doing fine, then what I would suggest is do an AutoML keeping just ElasticNet so that you can spend this half an hour and do this optimization on top of that specific model. Now, as you can see here, the best model is probably a voting ensemble, meaning a lot of models coming together and being combined. And because I have ordered explainability, I actually have over here the explanations. We actually provide you 2 explanations. The first one is the human readable one, the one that shows the features that we passed in. You remember the numbers, 0 to 9? These are the features we have over here. And over here, I can see the feature importance, meaning that the most important prominent feature that makes the selection of the diabetes level 1 year down the line is actually feature number 8, which can be actually the glucose, for example. And the next thing that makes the most important thing is actually the number feature 2, which may be the blood pressure. Over here, on the second explanation, I have actually the feature engineered. These are the features that the machine learning model was trained with. The model actually knows those features. And as you can see here, these are features that are engineered because we are putting an imputer here. So we are changing the values and we are just imputing the missing ones with a process. And this is why the model is trained on this. But of course, it's much easier for us to understand what is most important based on the features that we used on the dataset. In here, I can see the feature importance, and I can do various analyses. Like, for example, I can select over here feature number 8, and I can see here all the values of number 8 and the importance that it has to those features. What I can do is I can actually create a cohort. So I'm going to just duplicate this, and I'm going to call this feature number 2 greater than 0.1. And I'm going to select the filter dataset, and I'm going to select feature number 2, and I want to bring in those values that are greater than 0.1. Do you remember those outliers that I showed you before when I was investigating the dataset? So I'm going to just click save, and that's it. So as you can see, for this cohort, this is the F2G01. For this cohort, the feature number 2 is the most important value. That's a very interesting insight that I just got about a specific cohort that I created here. And if I want, I can jump even into individual importance. And over here, I have, these are all my training data set. This is the 442. I can focus on specific cohort, or if I go to my old data set, I'm going to just bring this record and this record over here and this record over here. And you can see these colors over here. And here are the importance for this specific, the feature number 8 is actually a negative. So actually, despite having that value on 8, the feature is the record is having the value that it's supposed that it has currently. And over here, I can show you, for example, let's select feature number 2 over here on the left. And over here, let me show you the predicted values. So, or let me switch this. I'm gonna select the feature number 2 here, and I'm gonna select the predicted value over here. So let me bring in the true value, not the predicted one. So basically what I can see here is that the more I go above 0.1, and this is my data set that I was looking at, these are the outliers that I had seen spotted in my data set, I see that their diabetes value is above 200. So this is why the feature number 2 is actually the most important thing, because these outliers actually reside on the high end of the diabetes level versus those that are over here where they are in the more normal space of 50 to 200 level. So this is the explainability, and this is how you can get insights regarding your actual model and the inferences that the model is making. Mir, would you like to take over to get us through the classification model?
Yes, certainly I will do. So just wanted to highlight one thing is, as you can see that the explainability feature, which is basically built in under the Azure ML run, it's a great feature. There are other features too as well, but it's a great feature to understand without writing a single line of code how we can basically take advantage of the platform and then get a good quick view of, based on the data and based on the problem that you're trying to solve, can we employ that, or can we employ the Azure ML to create the model of our interest and get the insights about all those models in terms of metrics, in terms of explainability, in terms of data control, etc. So I'm going to walk you through the classical classification model problem solving. So let me share my desktop real quick. For my problem, essentially, it's a problem of a bank reaching out to their customer base, so to gather some interest in a basically service that they're going to provide. Will the customer base be interested subscribing to that? So we call it a bank marketing problem. So for that, obviously, I have a data sets that I'm going to be leveraging. Let me show you the data sets real quick. This should be the data set. If I explore, so this is the data set that we have that we gathered, meaning the bank gathered this data set from their customer bases. Now I'm going to leverage this one in my AutoML. So if I can walk to new AutoML job, and as Andreas actually already walked through, I'm going to basically just go quickly select the data sets here. Is basically bank marketing is the data set for the data set that I'm going to be leveraging. Again, the problem area is essentially to figure out the customers should be interested for a service that I'm going to be offering. So I can leverage one of the existing experiment that relates to bank marketing, or I can create a brand new one. So let me create a brand new one, bank marketing data experiment. And of course, the target column for me is the Y column. This is a classification problem. The answer from the problem solution would be yes or no. Yes, they will be interested. No, they will not be interested. So that's why the target column Y is the one that I'm interested in figuring out in my model training. Then I'll select the compute type as compute cluster, because obviously this will help me scale based on how long I want to run. And then I'm going to select the ML demo compute cluster as my option. Now, as we looked at this page is algorithm. So in a classical data science problem, what do? We just have the data. We do the data feature engineering. Once we have the data, then we select the algorithm. Once we have the algorithm, then we can do our hyperparameter tuning, right? Configure the hyperparameters. That's essentially the AutoML job does for us without doing without writing any single line of code. Essentially, so this is our no code option. So since my data shows this is a classification problem, so I select the classification as an algorithm. Once I have the data feature engineering completed, I select that, and then if I want to essentially configure different settings, I will have to go through few additional configure settings. From the metric perspective, I'm looking for area under the curve weighted as my metric, and then obviously Andreas showed you other options. I'm looking for explain the best model option. This one you'd have to opt in, but at the same time this feature is automatically done for you if you opt in. And there are other, like, if I want to block a model from running, then those are the options that I can select. Exit criteria, training job time. Andreas showed you. Of course, I can do the same for 4.5, meaning half an hour. And then, of course, if I want to select a specific metric threshold, I'm not going to go to the details of it. Andreas went through this already, but just want to show you it's the same, essentially underlining additional configuration settings that I can select for my classification problem as well. I set this up selecting auto, but I could also say it's a careful cross validation. I could just go with that option as well. For me, I'm going to get to auto, and then I'm going to say finish. Once I click on finish, of course, it's going to run for half an hour. As Andrea explained already, essentially what it is doing, it is employing different algorithms on the data sets and basically doing the hyperparameter tuning as well for my model. So for the sake of time, I'm going to skip clicking finish, but I will show you one of the job that ran for me, and I can basically walk you through the job run and what happened behind the scene. So if I click on AutoML, automated ML link, go back, I will have to cancel this one. And as you can see, I have multiple runs. So let me see if I can select back marketing AutoML experiment one. And there is only one job that completed under that experiment. I go into the job. Of course, it shows the job completion details, the complete target it ran on, how long it ran on, all those details. And of course, if I want to look into the raw JSON for the compute run, it will definitely give me more details if you are interested in. Now, if we'd like to look at the data guardrails, what data guardrails basically is showing me is that if we recall during the data feature engineering, if we have, for example, the balancing problem with the data itself, the AutoML feature actually automatically detects that balancing problem, alerts it, and actually it takes attempt to fix that data balancing problem. So this is one of the data feature engineering automatically done for you. So that's where the data guardrail comes into play. There are other options as well, like high cardinality feature problem in the data. If this is a data engineering problem, and we know that we spend a lot of time in the data feature engineering, and AutoML basically automatically does that for us. And we'll keep adding different data feature engineering features so that it helps us in the AutoML world to quickly figure out the best model that we can employ, and then we can take it to the next level in terms of our Azure Machine Learning project. We looked at the data models as well, and just showed you as well. One of the things that I want to go over is that for me, for the voting and symbol algorithm was the one that was taken as a basically best model, considering the AUC weighted is basically the the best here, highest in this case, of course. And that's why I say if I look into the view explanation link, it will basically give me the same explanation that Andreas walked through. And as you can see, I'm not gonna go to the other ones, but most important to note here is that for the feature importance perspective, as you can see, the duration, the longer the customer will stay or stayed with the bank, the better is the chance that they will essentially opt in for the new service that you're going to provide. That's where the success of this campaign will come from. So without writing a single line of code, gathering the data and running through the AutoML, we can easily get details about what kind of model we can create, whether the model will be giving me the result that I'm expecting. Okay, so which customer is going to actually take the service? Those results will be automatically given for me without writing a single line of code. And we can go look into other aspects as well, like metrics, for example, and then outputs and logs. If we want to go to the outputs and logs, as you can see, you have explanation related logs and then logs as well for the runs that we can look into. And then the other thing that I want to quickly show you is if you look at the code, it will show you that the AutoML driver is the driver. You could easily take this driver, download it for that matter, and then review how essentially behind the scene, the AutoML created generated the code to run the training pipeline for you. And then essentially, if you want to extend from there on for your bigger machine learning project, you can take it and just modify it the way you want to. Now, once I have this particular model, if I want to essentially deploy it, there are a couple of options that I can use to deploy it. One is the deploy to real-time endpoint. One is the deploy to web service. For our exercises, we can say, okay, so I'm going to go ahead and say deploy to web service. And as you can see, there are a couple of options, Azure Kubernetes service and container instance. For me, I'm going to go with container instance just to show you. This is what I have. I'll have to start it though, but I'm going to say 2 because I already have one. And if I just say deploy, it's going to deploy the model. What happens when you deploy the model? So if I click on deploy, essentially, let's click on deploy and let's see what happens. But essentially what it will do, basically, it will create an endpoint for me based on the models that is deployed. It's, for example, I have multiple models that are deployed, credit default models. Of course, that's not related to my AutoML, but for the AutoML that I have, actually, this is the one for the AutoML, and that's the latest job run, May 27, and that created the endpoint for me, right? And then, of course, you can look into the other options. Like if I go to endpoints, and bank marketing AutoML endpoint July 7, it's being deployed right now. As it deploys, it will come back and I will see if I can start it on. So this is the one that worked for me before. It is in the failed state simply because I need to start the container instance. So if I duplicate this tab, I will go to actually portal view. I'll go to container instance, container instances, because that's where it is being deployed. Bank marketing AutoML deploy. This is the one that I last ran. Before that, I had created default one. So let me see which one essentially is behind it. I'm going to go ahead and this was stopped. I stopped it to avoid charges. So I'm going to go ahead and start this one. I'm going to also go ahead and start this one as well. And then once it gets started, you will notice that this will become healthy. What my goal is, once it becomes healthy, then definitely I'm going to go ahead and show you how we can consume it. So that's the goal. But the idea is, once you have the model created, model registry will update the models that being actually deployed into the deployment option there. So for example, if I select this one, I could easily see multiple options, right? That's not where I did it, but what I did is I did directly from the runs, from the jobs that I had. So I can go back to the models. And again, I can go back to this ensemble model and I can say, okay, I'm going to go ahead and deploy this particular model. That's the option that I selected, right? But then obviously, if you look at the life cycle, you train a model, you then register the model. Those are the steps that happen behind the scene. And then once the model got registered, from that model, essentially, that's the last one that got registered. Essentially, I also have the endpoint created for me as I was going through the process of deploying, right? So that's what. So you see, this is the latest one. Let's say if it is healthy yet, it's healthy right now. I could easily now look at the health status by navigating to the rest endpoint. So if I say, what is the rest endpoint? So it says, what is the status of the rest point? It says healthy. And then if I want to look into the essentially Swagger view of it, that gives me the details, I could easily go and look into the Swagger view. I could say open in a new tab. This gives me the detail. Now, to get to the detail in a formatted JSON, I can use the JSON formatter. I can take this Swagger output, put it into JSON formatter, and it automatically shows me how I can interact with that the endpoint. So essentially, it's a deployed endpoint for inferencing. That's what I can do as a test as well. But to look at what I can do is basically I can do a post, and for the post, the way I have to interact with it is basically I'll have to give this data. So let's just go back and let's just say how I can test this endpoint that I deployed. And if I look at the JSON editor, so this gives me the format of the data that it is expecting. So I have some pre-canned data that I can easily use. So I'm going to copy that data and paste it right here, and I'm going to say test. So based on the data, it's going to just quickly come back and say, okay, yes, this customer will be willing to essentially opt into the service. So without writing a single line of code, what I did is I had a classification problem of the data. I went through and created the model, registered the model, and deployed the model. And if you look at the model itself, then of course you can look into the details of it. I didn't have to write any single line of code to do all of this. Now, if you want to use, so let me go back to the endpoint one more time, this one. If I want to consume it through other programming language like Python, for example, I could easily take this example and consume it, or I could just use the Power BI to consume it as well. So that's the AutoML experiments.
Can you select, I'm going back to Spark pools, sign up Spark pools. Can we deploy this way to a Spark pool?
Very good question. So the right now, the way that option that I see here is that basically, so let me open this up one more time. Let's say this is the model that I want to deploy, right? So you see, we have the option of deploy to web service, deploy to batch endpoint, deploy to real-time endpoint, right? Those are the options directly had. We should be able to do that as a target, but unfortunately, I don't have a way to show it right now, but it's a very good question.
Thanks.
All right, so we talked about the AutoML for classical integration problem, and then we walked through the options of training the model, registering the model, and the deploying the model. If you look at the pipelines, this is interesting, and so it's a created default pipeline. This is the one that we ran, essentially, total credit default. And the interesting part of it is that behind the scene, not only did it train the job, but it did train the job in such a way that it actually automatically created a pipeline while it got the data, did the data feature engineering, and then they picked up the algorithm and did the training for me, all in typical pipeline way. And we'll see one example in the code viewer. Essentially, it just walks you through the entire process automatically for us, but we recommend you to build the pipelines, because that way for your own machine learning modeling, you can do everything like data preparation, then model training, then registering. All of these three could be done into the pipeline and could be reused wherever you need to essentially employ it later on in the life cycle of machine learning project. So that's why, I mean, you could do it separately, but pipeline is the recommended way to do that. And this is just showing you how the pipeline is going to look like. So that's why I wanted to tie this back to the pipeline. Environment is interesting, right? So what environment does is basically, as it shows, if you want to train a model, you need to compute, you need your code for the model itself, then you need a curated environment or a custom environment where you can put all the dependencies on it. All those together will give you the runtime, right? So environment is essentially one piece that is basically that you care. We started creating the curated environment, as it shows you the curated environment we started creating, because we can see that you really need an environment, and it takes time for you to figure out how you put that together in a Dockerized format. So rather than having you spend the time, we'll just look at the most common environments and put it together so that you can just pick it up. And on the code view, I'll show you how it comes back to. But essentially, that's what the environment is. The dependencies for your algorithm, for the machine learning problem that you're trying to solve, the packages that you need for if it is Python related, all the Python packages that you need, all those comes into the environment and goes together when you draw basically start the experiment or run the experiment for the model to train your job. So that's where the environment comes into play. So pipeline environment models. Components is the one that essentially we don't spend a lot of time. It's basically a way, as it says, basically performance specific to data processing. So essentially, if you look at train credit default models itself, it created the component train. It almost seems like one part of the overall pipeline train credit default model. It just componentized that particular aspect of our overall pipeline. So those are few of the aspects, the manage aspects, the authoring aspect that I wanted to get details.
What I could add about the components is that the way I think of it is a way you can package a piece of code, and actually you can, if you switch to the code tab, you will see that code and an environment. So basically in here, I see that you have this train.py code, which will be executed. And a component consists of two things: an environment that is going to execute that. So the environment that is going to contain all the dependencies needed by your piece of code to run, like the SQL or DBC driver that we mentioned before, and the script. And this allows you to package it and even define those inputs and outputs for that component, and then you can drag and drop it into your designer, and you can create those repeatable assets that you can use. For example, I had a customer that created one of such packets that was doing a data analysis on top of an incoming data set, and he was specializing, he had his own reports and seaborne graphs and Plotly HTML outputs, and then he was outputting all of those things into a storage account, and then he could easily, drag and drop the data set, add his component that he just registered, and then he was doing this analysis that he wanted to do.
Fantastic explanation. Thank you for pointing this out. And of course, I think it's, I mean, if I go back and look at like data preparation for training, right? So if I look into that aspect of it, I think all of these are tied back to the like data preparation training. So if I go back to the pipeline itself, right? Look at this credit default pipeline one more time. See how different components, data preparation for training, data train credit default. Those are all the components that you see has been created. That creates the reusable unit. I can take all of these and then expand on for my full-blown classification bank marketing problem. So next, I'm going to go to the notebook option of authoring. So in the authoring, of course, we have a designer view. Once you go through, let me show you just one of them. It's like automobile price prediction real quick. It's a drag and drop options, right? This is the component. This is one of the components. This is one of the components. You just can drag and drop the components to put together the pipeline view of it. And essentially, you can just do something similar to automated ML without writing code. So this is also a no-code option, low-code, no-code option for your authoring experience. Right, as you can see, I have a linear regression algorithm that I have. I split the data, I cleanse the data, all those components. I just drag. See, this is where the components comes into place. So the train, default, credit. So all those components I can drag and drop. And then I also saw that there is a Python, custom Python code component that you can drag and drop to do something with the data itself. But the idea here is that, you know, if you are not a data scientist, data engineer, but you need to put together something as a, like, you know, proof of concept without writing code, either AutoML is probably our recommended option, or you can go to the designer view to drag and drop to put together a pipeline for a problem that you're trying to solve with AI. For the data, you have the different components, the different options. Like it has a COCO data set that Andreas was talking about before, my marketing data sets, images for tutorials, and there are other data sets that I created. You have to create those data sets though, or you have to have the pre-canned data set that are available for you. And then component is basically your algorithms, and then other like, you know, split data mechanism or other mechanism that is available for you. And then the training component, scoring component, all those are available. So if I search for train, as you can see, it's a train model component and clustering PyTorch, different options are available. Now that's one authoring experience you can take advantage of. But if you are a data scientist with the love of your own controlling everything through the code, that's why we see most of our data scientists spend the time using the notebook authoring or notebook authoring options, right? So I'm going to go through one example or few example codes just to show you using the SDK, Python SDK, you can put together a notebook coming here. You could say, okay, so I'm going to create a new notebook, right? I'm going to go ahead and create a new file, which is the notebook. So as you can see, it could be a Python notebook, or it could be a script, it could be R, Bash, other options. But for us, if for a data science activity, I could say test notebook that you can create it. I have few that I'm going to walk through. The idea here is that using the SDK, of course, I'm using the SDK version 1x, but please note that version 2 or V2 of SDK is out there as a public preview right now, and we are doing lots of testing with it. And then the one recommendation for us to actually walk through and just test out in different scenarios. For us today, I'm going to go through actually version 1. So you'll see when you have a notebook created, a few things that we do. We make sure that we bring the AzureML SDK. If it is not there, we have to use the pip to install it, or other mechanism to install it. But right now, the environment that I created, it already has it. All I have to do is import it because I'll need the SDK. The workspace, as you see, everything that we did through the UI, we could do all of those through the code SDK. And for that, the starting point for me is going to be the workspace itself, because that's where my data stores are, that's where my computes are, right? So I need that.
I would like also to mention here that if you remember in the beginning of the session, I showed on the top right corner from where you can download this config file, and that contains the pointer to the workspace. So basically the command that Mir is showing right now, the from config is literally trying to locate this config.json file, and it's trying to figure out to which workspace am I supposed to connect, and then it's using a handful of identities to actually go and connect to that. Right now, Mir is using the notebook, so basically Mir's identity is going to pass through to be able to connect. But if I was running on a compute cluster, the same script, it would have assumed the identity that is associated either as a managed identity on top of the compute cluster or a service principal that would have been assigned on the environment, et cetera, et cetera. This is a notebook experience that feels very similar to the Jupyter notebooks and the Jupyter labs that we also support within the compute instance. The main difference and the reason why we built this separate UI experience is because we wanted to bring our own experiences with the VS Code editing tools. And if you can see, if Mir, you can add a new cell and add start typing import OS, you will start seeing the intelligence and the richness of this UI experience. So if you do import OS, a new line, and start typing OS dot, you will start seeing exactly this, that you can select, okay, let's select path and then click dot, and let's see the options that we have over here, which is the join, perfect. And then let's open parentheses, click enter and open parentheses. And over here, I can see the arguments. So basically, in order to use a path join, which basically gets a directory, some directories, and creates the full path for this, I can pass the A and then whatever else path I want, A, B, C, etc., etc. So I get this rich intelligence, which would have been impossible for us to provide with you within
Jupyter
notebooks. And another experience that I would like to show is if you see on this cell on the top right, on the right side, you will see that you can convert that into a markdown cell, the first one, and you can clean outputs, but you can also, yes, thanks, show the options of the second one, and then the third one is the one that I wanted to highlight, which is, this is just a clear cell, the new comment. And this is where the beauty comes with the workspace, because you have multiple data scientists working on artifacts that are stored in a common shared file share, the one that I showed you in the beginning in the storage account, the code file share that we saw in the storage account. We can actually start commenting on the work of our colleagues. So we could have shared notebooks and we can start putting comments and they can reply to us and all this type of collaboration that we can get. And this is only achievable through a custom UI like the one you have, Mir is showing here today with us.
So it's a very good point you brought up, Andrea. So here I want to highlight something. So think about it. Myself and Christina, we are data scientists, you are an admin, right? If we are working on separate Python notebook, so we should have separate compute instances, separate Python notebook, separate problems. How do we share with each other? Because I mean, just to point out, this users directory is essentially, it's a you showed this us earlier. This is part of the file share, right? Under the file share, we have for each user there will be files, right? So will I see, if I come in here under the notebooks, well, will I see Miral as well as Christina as the users? Will I see that? And then I should be able to click on Christina's the notebooks, or how do we essentially, going back to that commenting recommendation of the tips, how do we essentially do it? Will I see it here, or will there be a common repository that we can create where all our notebooks will be available? Everyone comes in will see that particular share, and they should be able to work off of that.
That's a great question. There are two approaches to this problem. And I just shared with you a link to one of our blog posts from Abby, who was presenting in a build. And he's showing there a couple of collaboration and productivity enhancements that we have within Azure Machine Learning Workspace. And if you open it, there it talks about the preview feature that allows you to do collaborative editing on top of the same workspace, on the same notebook. So if you scroll a little bit more down, you will see the experience. It talks about IntelliCode, the thing that we just mentioned, and over here in the collaboration, you will see that over here you can co-author, co-edit a notebook. This is in preview. I'm not sure of its current status, but this is the experience we were building from the very beginning, from the very inception of this product, right? So coming back to your actual question, what I have seen with enterprise customers doing is that they have a common folder where they have all those modules, libraries, these packages that are developing for their machine learning. So like if they are building their own neural network and they're defining their own structures and all this type of things, they have a shared code base where they are editing this, and then they can use that shared code base by importing it inside their notebooks and then collaborate, experimenting on their own, but having a shared code base which they can use.
They put it on a share repo like GitHub, something like that, or they put it some common folder structures or the inside the blob storage itself?
That's a great question, and that's where I was going. So the very first approach, before we even get into Git versioning, when you're on the very early stages of prototyping and probably you don't even have a Git repository yet, it's just a shared folder right next to the Azure Machine Learning Workspace. And it is stored in a file share. It has 3 replicas. If you go and you make geo-replication on that storage account, you even have more replicas. So it's quite safe to put it there. But of course, once you want to start making something useful out of that, then you need to start versioning that. And that's the second stage, where you have a Git repository and each data scientist is working on his own branch. And all the data scientists are collaborating on their development branch, where they're pulling the changes on a daily basis. They're pushing their changes whenever they feel they have completed their task. And this collaboration is keep going, and it's also traceable. It is within either Azure DevOps or GitHub or whatever the tool of your choice is on Git that provides you Git capabilities. You can review this history of commits and who changed what and all this type of things. So this is why the most enterprise-ready customers, they start directly with a Git, right? Because they want to maintain this history and this traceability of who has done what.
Okay, fantastic. Very good point. So let me move back on then. So on the notebook experience, then I guess the idea is basically you do everything using the SDK, right? So when it comes to experiment, we walk through in automated ML as well as discuss this under the jobs. If you're looking at the experiment keyword, you will see a discrepancy because the experiments typically is not available anymore in the UI. The idea is they actually convert this into a job concept, right? So you have jobs. Each job will have a name, which is basically bigger umbrella is still the experiment, but there will be multiple jobs under the experiment, right? So that's why it still is relevant, but you won't see it on the left side. But again, you'll see that SDK V2 will have a different way of interacting with the experiment. There will still be experiment name. I have seen that. But notice how they actually showed us how to do this. You create the experiment name, you run the logging for the experiment, then you just work off of your data, that you process the data. Once you have the data, of course, you just put together your model code. Of course, once the model code is essentially done, then as you can see, all of these are related to your modeling, right? Done, then essentially you say, okay, the run is complete. So all of those are associated with the run. So if I run this one, it should be under a job at this point. So let me go ahead and quickly run this just to show you.
In this code, besides the first 11 lines, from line 14 onwards, this is normal Python code. This is the Python code you would have written on your own notebook or inside on your own machine. What we are doing is we're augmenting that code, and we are adding you these logging capabilities that you can see in line 18, where you can start logging things. And when you log things, instead of logging them on your local computer, you are logging them inside this workspace, the environment which you can share with your colleagues, and you can show them graphs, you can show them these images or artifacts that you have shared. So it's an easy way to collaborate. And please run this code so that we can actually explore the artifacts that you just logged there. But the rest of the code, it should be very familiar with you. You can run whatever Python package you want or whatever library you like. Even you can adopt the most famous MLflow library that is doing the famous auto logging capability when you're training models and stuff like that. And Azure Machine Learning server is a full-blown MLflow server. So it can log for you those metrics and the models that you're registering with MLflow.
Cool. Thanks for the explanation. So as you can see, of course, it is telling us that, okay, so we started this diabetes experiment, and then it shows me based on the data, of course, it's the diagnosis is number of patients chart, as well as analyzing number of the rows of data, right? So if I want to see where this goes in, you will see there are jobs. The new jobs is being, so that's a diabetes experiment. So still we have the experiment concept, but if under the experiment we have multiple jobs that ran, this is the latest run. So that's why this is still related, still all the components are there, but essentially everything that you, and if I look into the outputs and logs, we'll have the outputs as the samples that we have, and then we definitely have the logs that we could just go take a look at, right?
If you go to the metrics, we will also be able, yeah, this is the distribution that you log. Yeah. Here are all the metrics that you log. And what I would like to also highlight is that if you go into the overview, you will see something beautiful happening that if you see on the second column on the bottom, you will see Git repository. And you will actually see that without even mere talking about a Git repository or something, I actually have a Git commit. I know exactly the version of the code that run this experiment. So I can, with these experiments, I get this automatic traceability between the actual code that I have version control within Mir's GitHub account, and exactly the specific Git commit on the branch that's called master. And the metrics and the outputs and everything else that I got. And this is shareable with everyone that has access to this workspace.
Just want to highlight the fact that this is the integration that we had been talking about earlier, where the idea here is that we have a common place where you can put the code, and then for the versioning control, best is of course go with the Git, right? So thank you for pointing this out.
And another point here is, as you can see here, the Git repository is being logged. So I have seen some data scientists using username password in the URL, like username dot password or access token, and then at github.com and stuff like that. Please do not use that. Please use SSH keys, because as you can see, things get logged and your password may be leaked.
Get it exposed, right?
Yes.
Yep, absolutely. Very good point. Okay, so going back to the notebooks, and of course, this is how you can, I have other things, for the sake of time, I'm gonna bypass those, but I have one more that I can walk you through a little bit that has a pipeline flavor. So this example essentially works off of data lake store data. I still have a Python notebook. The one that I want to highlight is we talked about data stores and data sets, data assets rather. So this code essentially shows you that I can get the data store and create the data set using the SDK. That's one highlight of these particular examples. And in this case, the data store happened to be Azure Data Lake Store. Then, of course, the second highlight that I wanted to go over is that I still have the experiment concept. Andreas was showing, was walking us through how we can take advantage of the libraries, Python libraries like OS in this case. I am taking advantage of the Python libraries, making directory API off of this the library. Then to componentize or basically create the code in such a way that we can leverage, I just created the Python script, right? I created the Python script. The idea is that each of this unit of work that I need to do, training a job, registering, training a model, registering a model, and then of course anything, so data preparation, for example, if I need to do, I can have those units of code separately and put those into a component. So if you recall, we looked at that components. That's what it is related to. So it's essentially that's what I'm doing here. I created a code that I can put it into a component. So this one is for the training job, and it's a little bit code, but it's not. That's not nothing fancy for a data scientist. They do all sorts of codes, right? But what important to me is that I have a training code, then I have a register code separately. Then this is what the environment information also is related to, because we talked about the environment, talked about the compute. Notice how I actually have a compute created here. This one is essentially compute cluster, not the compute instance. Then I have the environment or dependency that I created. So this is the YAML where I am defining all the dependencies. Once I have that, then I can create the environment programmatically off of that specification file. Of course, I can register that environment. I didn't do the register, but I'm leveraging that. So all of these for the pipeline run is going to go into the run configuration. I put the information for the cluster that I'm going to be leveraging, the environment information that I'm going to be leveraging. Then I created the pipeline itself. So if you look at the pipeline, I have a script run config, which basically is starting the pipeline route, and then I have several steps in the pipeline: training step, registers. I don't have the data preparation step, but all of this essentially is creating the pipeline or the step approach that we recommend to leverage. Now, once I have the pipeline, essentially I'm just putting the pipeline steps. I'm putting this pipeline together, and same way I'm just submitting the experiment for the run. Once it runs, essentially it's going to do the same thing. It's essentially, so let me see if I can run it from the beginning.
So first and foremost, if you leave your mouse on top of something, you've seen these pop-ups appearing with the documentation of from Python libraries and what this is supposed to do. Another thing I wanted to show is, yeah, exactly like that. This is the documentation coming directly from the library. Another thing I wanted to highlight is that Mir showed here how you can do the write script trick, where from a notebook we are writing a Python script. We all know that this is not the best practice, but if you are working on a notebook and, for example, the training script where you are reading the data, you're training the model, and then you're logging all those metrics, what you can do is, Mir, if you can go into the burger menu of the editor, you can actually, on the top there, exactly, you can actually do export as, and from there you can export as Python. It's a little bit to the third from the below, exactly. So you can literally take a notebook, which basically it's a JSON file, and you can convert that into a Python notebook, a Python file, a Py file, which you can then use. So instead of generating a Python file from the notebook, you can just export the notebook into Python. And then, of course,
Yep.
you can use all the tools, the standard tools, the software engineering tools that we use, like Black to format the code and Flake to run for linting and all the other tools that you may be using for your Python development.
Oh, fantastic. Thanks for the tip. This is very useful. So let me see if I can run this one real quick. So I have a train and register steps. Of course, I could just, instead of, so look at how we could just use, look at this line. So environment get, and I could just go to the workspace and just get a curated environment for me to run the same thing. For me, of course, I'm just showing it how to do a custom environment. I didn't register the environment. If I would register, it would create a Docker image for me. So then if I create the pipeline steps here, I'm just defining the steps.
Let me talk a little bit about the environments. If you are behind the VNet where you have limited access to the internet, where you probably don't have access to PIP or Conda, then curated environments come into rescue, because we have brought you, we bring you all those environments that you can use for training and inference. Having all those PIP packages pre-installed and being checked that there is no supply chain attack into those environments that we have and all these type of things, right? So, and keep in mind that there are two versions of environments: the ones that are for training, which are, they don't have inference in them, and then the inference ones, which are very slim ones and contain only the packages needed to operationalize a machine learning model and make inferences. So that's the difference between these two curated environments that you will see in the environment list.
Yep, oh, fantastic. Thank you for pointing this out. So we started the pipeline. Let me see. It should tell me there should be okay. So the one that is completed, of course, for earlier. But sometimes you also see notifications while it's running. But here, it is actually giving you the pipeline run and etc. and the link for it. What I wanted to show you is that now that I started that pipeline, it's running, I should have a job running. And that's the pipeline job data set 2, right? And then it should have, if I go inside it, it should have a latest job running. And it should have the pipeline view. This is what as you can see, if the designer, we have the same view, and it just basically you created this pipeline through the SDK. And of course, we are showing it through the SDK V1. V2 has its own way of doing things. It's going to change. I want to have a caution on it, because I mean we're changing the naming and etc. But please to note that the concept is the same. We do have the pipeline that is being created. So just the naming will be different in terms of the libraries, how we are putting it together.
Exactly, and basically it boils down that each of those components that you see here, each of those steps, it's a set of scripts, Python or R or whatever else language you may be writing, like .NET, Go, or whatever else, and an environment that has all the dependencies to execute. This is exactly what each of those steps is, besides the first one, which is a dataset, right? So. Yep. And either you do it in SDK V1 or you do it in SDK V2 or whatever we have in the future, it's going to be exactly the same. It is basically an environment that contains all the dependencies, a piece of code that gets attached to that environment, and it's being executed. And then you have those inputs and outputs that basically make the connections between the steps. So the reason why those two steps are not running in parallel is because step 2 is waiting for data that are outputted from step 1. This is the only reason why
Correct.
step 2 is not actively running right now. And that's also the improvement that we bring in with SDK v2. We are streamlining this process and we make it crystal clear that this is how you define a pipeline. And another thing that I wanted to point out on this designer is that it looks exactly the same as if the designer that you saw before. And that's on purpose because everything you see here is the designer that you saw before. This means that you can click on the publish button on the top and you can literally publish a pipeline, an endpoint that whenever it's triggered by HTTP request, it will be triggering this pipeline to execute again. And this is something I have seen with customers adopting V2 version, where they're defining these pipelines in these YAMLs. They execute it once to verify that it's running, and then they just go into the designer, then click publish, and then they schedule this job as it is feasible right now with the SDK v1.
Fantastic. At this point, I'm going to stop, pause. There are some other codes that obviously we could go through, but those are basically maintenance, like, looking at different aspects. I mean, we could literally here, there is one other thing that I'm showing is if I wanted to deploy this. So we have a model registered to the pipeline. Once it's being deployed, once it's being registered, that how could I deploy it? So to deploy, we need a script file just giving enough information as far as how we can do the inferencing on it. That's where the script file comes into play. And they, of course, the other information like dependencies and stuff like that information. And once we have that, then we need an inferencing config information, as well as where am I deploying. In this case, of course, I'm just deploying as a say web service. As if you recall, on the deployment for the model, we had the web service and we have the Kubernetes as an options. We have the same options available through the SDK. This is exactly what I'm doing. And then, of course, once it is being completed, so I think it's the pipeline is still running. Otherwise, so essentially, so you need the script file, you need the environment information, you need to put together the inferencing configuration information using that script file and the environment, and then you can essentially create the deployment configuration for the type of deployment that you want. In this case, the web service. As you can see, I can say model to deploy using that information. Once it's being deployed, obviously it's going to come down to endpoints, and of course we walk through how you can consume the endpoints after it is being deployed, but at the point that is being deployed, it's going to come under endpoint. So I do have one. It's not going to probably it should not be in a good state right now, but I just want to quickly show you with inference, right? So it does have those same says failed because it's unhealthy, because the container instance, this is a web service deployment where I deploy it, the container instance is not running, so that's why it's going to show as like unhealthy right now. And of course, as you see, I don't have any other information available, not the Swagger URI, not the REST endpoint, but at the same time, that's where the code comes into place. The entire, if I look at the entire developer experiments through just the SDK, starting from registering model code creation, training the model, register the model, and then once the model gets registered, you deploy it, and then once the deployment is complete, then you can come here and say, okay, I'm going to go ahead and consume it this way. This is the sample code that we saw available in some fashion in the UI itself. Of course, mine is very simple one, but it just does the same thing. It just basically goes against that deployed endpoint and do the prediction. So entire life cycle of the model is being basically reproduced to the code, and this is probably what we see for the most part with our customers. But of course, we have all the facilities that I wanted to walk through today.
I have one last comment on this inferencing side, and that basically the scoring is about loading the model, which is the init phase, and making the predictions. This is the global truth. This is what you have to define on how to score, to create those real-time HTTP endpoints. And that it doesn't matter if it's V1 or V2 or whatever it is, it's just we're moving towards a place where you can operationalize in much more flexible resources rather than being constrained between ACI and AKS. And that basically there is also another option which we didn't cover, which is the batch inference, which is a much more cost-efficient approach. When you have, for example, if you want to run a machine learning model and make the next best action for your customers, you can run this in batches. So if you have 80 million users, right, and you can run 4 million a day, and then you can make those inferences, store them in your database, and then when your sales team wants to contact a customer, they can go in and figure out what is the best next thing to offer to your customer. And this can also be done. In that case, again, you need to specify how do you load the model and how do you handle a batch, a small batch. So that's how it's going to be, either if you're using SDK v1 or SDK v2 or the CLI v2 or whatever else we will bring in the future.
Cool, fantastic. Again, just to close out, the idea was to basically walk through the entire Azure machine learning experience for your machine learning projects in Azure. So would love to definitely love to have some feedbacks as far as how useful this talk was. And I'd like to definitely thanks a lot to Andreas and Christina for joining with us and walk through the examples, the concept itself. All of those are great great assets for us internally as well as externally for our customers, so that we can help them quickly get up to speed with Azure Machine Learning service. That's all from my side. Anything else you'd like to share, Christina and Andreas?
Thank you so much both for your time.
Thank you.